So here we have the 3 NEMA 23 stepper motors that comes with the makerslide.co.za kit. And we have 2 that we're going to be using on the Y-gantry plates, and we have another one that we are going to be using on the X-gantry plate. For this we are going to need a spanner for these nuts. It's a number 8 spanner, and we're going to use, it's a number 4 or a 4mm Allen key. So for this particular exercise you will also need they measure about I think it's 21mm and they are M5 bolts, and also M5 nylock nuts. You will need 4 of each. So I'm not just thinking how I'm going to be orientating my wire, because we obviously going to need to be doing some wire management in this process as well. But that should be easily fixable or changeable just by swapping the motor around. So for now, I'm just going to let my wire come out that side. So you might find that these holes are a little bit small sometimes. So what I've done is I just used a utility knife and I just scraped out the epoxy coating that is on the inside of this. However, I'm still experiencing a little bit of problem. So I'm going to just swap out to another motor and see if it's better, and then we can sort out the problem later, or perhaps that one fits better into one of the Y-axis holes. So this one's a little bit better. I'm going to try the third one. Quite still tight, however I'm going to see whether I can actually tighten these with the bolts that I have. So let's see. I think that's enough. Let's do the bolts at the bottom. And this is where it does become a little bit tight. So getting these bottom bolts and nuts in are actually a little bit tricky. But with a little bit of patience, it can be done. And now we can gradually tighten the bolts on each corner, and hopefully we will be able to pull this motor into place. Right, so that seemed to have worked fine. I can still probably get it a little bit tighter, but for now that is where I'm going to leave it, and then we can always come back later and make sure that that is tight. So I'm going to move on to the Y-gantry motors. So hopefully this is going to be a little bit of a simpler process. Again, I'm going to be running my wires towards the back. This motor fits a little bit better because I've already scraped out some of the paint on the inside of that hole. Right, let's tighten these up. We don't want these motors to come loose during operation. Right, and then I'm going to do exactly the same on the other side. Right, so we're back on the other side. What I am going to do is, again, position the wires towards the back, because in either one of the left or right motor, we're going to have to thread these wires through a hole in the gantry plate all the way through the extrusion to come out the other side. Right, so next we need one of these geared pulleys over which the belt is going to run and allow the gantries to move backward and forward. And this just fits onto the shaft of the NEMA 23 stepper motor. So you'll see there are two grub screws that we can adjust. So that end goes in first, and then what we're going to do is we're not going to fix it into place right now because we want to first install the belt, and then we can position this and fix it with the grub screws. So you will see that you also received the belt that will be driving this machine. And to fix the belt, we have 4 of these little brackets. So I'm going to show you now how we are going to install the belt onto the 2 y-axis and x-axis. Right, so what we're going to do with the belt and these little brackets, we have to thread the belt through. So we're going to thread it through the back hole with the teeth showing down, and then we're going to bring it back through the front slot with just enough belt left there so that we can have the teeth interlock like that. Right, once you've done that, we can push the bolt through from this side. Push it through the hole. And use the lock nut just to secure it in place there. So we want to probably not take this all the way, so that because we need to tighten the belt, and it would be good to have some space there so that we can actually do that. Now we're going to run the belt over the bearings and over the geared pulley, and then we're going to do exactly the same on the other side. Right, so I'm running the belt under the first bearing, over the pulley, and then under the second bearing. And then I'll reposition the camera to the other side, and we'll install the second clip. Right, so on the other end we want to do exactly the same and I'm going to try and see if I can just sort of guess where I need to cut this belt. We don't want to cut it too short, not too long. I think that should be sufficient. Again, I'm going to go through the back slot. Whoops. Sorry, made a mistake. Through the back slot from the top, down through the bottom, like that. Perfect. Bolt through. So I can feel there's a little bit of flex in the belt. I'm not entirely sure how much it should be tightened, but what I'm going to do is I'm just going to give myself a little bit more room to work with here. There we go. Just by moving the belt. I went the wrong way. There we go. So this is always something that you can come back to and adjust later. Right, so the belt is not tight, but like I say, I'm not sure how tight it should be, but we'll come back to sorting that out later. So what I'm doing now is just running this a little bit up and down so that we can see where this pulley runs. And what I'm doing is I'm just pressing it in a little, or you're going to have to pull it out a little so that that belt runs in the center of that pulley all the way through. I'm going to line it up so that I can see the grub screws, and then I am going to tighten the grub screws onto the shaft of the motor. You want to make sure that these are fairly tight. And there we go. It's running on the belt. So on this side, I'm just going to do exactly the same as I've done on the other side of the Y gantry. So again, we're just checking that this pulley is running center, and then we can secure the grub screws onto the shaft. Right, so with we have two remaining brackets, and with the remaining strip of belt, we're just going to do exactly the same on the x-axis as we have been doing to the y-axis. Threading the bolt through, and we have a lock nut on the other side. Right, so we're going to take the geared pulley, slot it over the shaft. We're going to take our belt, slot it through under the one bearing over the pulley, and then again under this bearing. There we go. Okay. So I'm just going to tighten it slightly, just pull it tight. So putting the belt tight, just cutting it to length, just on the other side of the plate here. There we go. Take our bracket, work the belt through. Maybe a little bit more. That's too much. Slot the bolt through. Which is a little bit tight. Nut on the other side. And we'll tighten the nut to stretch the belt. I think we can go a little bit more. Right. And our gantry moves smoothly. Don't forget to position the pulley. And secure the grub screws. So the kit, it doesn't come with any wires. I went to Communica. I'll put a link in the description. It's communica.co.za. And I bought a 4-core screened wire. I bought about, I think I bought about 20 meters of this. I don't know if I'm going to be using all of it. But we will see. So this is a 0.5 millimeter foiled screened wire, and it has 4 cores. So it's 4 wires inside there for each motor. So what we need to do now is, in order to link up the motor on the other side of the machine, we have to put this through one of these extrusions. So on the side here you can see there's a slot, and I'm now going to feed through this wire through that extrusion so that it comes out on the other side. There we go. Right, so I'm just going to reposition the camera, and we'll go to the other side. So now we have the cable that is fed through the aluminium extrusion, and it came out on the other side. So I'm just going to strip this off so that we can connect the motor wires and this 4-core screened wire together. And then we're going to remove the foil. And I'm just going to strip the ends. Right, now obviously we don't need all this wire that's on the motor, so I'm going to cut this a little bit shorter as well. I think round about there should be fine. And we will strip these wires, the ends of these wires as well. Right, so it's important to keep the same colors together. So my 4-core screened wire doesn't have a black, so I'm just going to substitute that for the yellow. The rest is fine. We've got green, red and blue. So I've got a few pieces of heat shrink tubing. Just a long piece that's going to fit over, that's going to sleeve over all of these. And then I have a few smaller pieces that are going to sleeve over the individual wires. Right, so now I'm going to just twist the wires, the ends of the wires together. Just remembering to keep to use the same colors on both ends, and then I'm just soldering that joint. And we can then pull the heat shrinking over. And just black goes with yellow. So the next step is just to use the heat gun and shrink the heat shrink tube. We can then pull the yellow heat shrink tubing over everything else. It seems my heat shrink tubing is a little bit small, but I think we can make it work. I'm going to pull it all the way to the end there, and then we can use the heat gun to shrink it. And then we can just push that through, and there you go. So on the other side of this gantry wheel is going to be doing exactly the same. I just snipped off the wires short, stripped the wires on the cable that we're going to be connecting, added some heat shrink tubing. So now I'm just going to solder all these together exactly the same as what I did on the other side. So try not to get too big blobs of solder on these joints, otherwise you will struggle to get the heat shrink over. And then remember, we are connecting black with yellow. Right, so let's get this heat shrink tubing over. Right. And I'm using the heat gun just to shrink these tubes. I'm just going to wait for them to cool off a little bit before I pull the yellow heat shrink tubing over. There we go. All right, so what we are going to do is we're going to be doing exactly the same with these two motors. We have this one and we have the smaller NEMA 17. So I'm not going to show you how I go about doing that. It's exactly the same as just the the ones that I've just showed you. So just go ahead, do exactly the same, connect the wires up, and then I'll be back after that. So when I ordered my Wasteboard, which I'm going to make from a 16mm MDF board, this is just the offcut that I'm going to use to explain to you. I ordered it so that it fits inside the brackets and on the, well, basically inside the confines of the aluminium extrusions, which works out to roughly 1 meter by 1 meter. However, there's a slight problem when you want to try and push. If I had to place the Wasteboard on here and try and push it right to the edge, the gantry plate and wheels is actually in the way. So what I'm going to do is I'm going to loosen this bottom extrusion, and I'm just going to move it in slightly so that I can have my Wasteboard sit on the entire surface of this aluminium extrusion. So it'll be like that. And then I'm just going to cut my Wasteboard slightly shorter. So when the gantry moves over into this position, the furthest it can go anyway is about there. So you don't use that part of the Wasteboard anyway. Right, so I've used the Allen key just to loosen this extrusion. I'm now just going to slide it inwards, and I've decided on sliding it inwards with about 20 millimeters. So I'm just going to measure 20 millimeters in from the edge, and then I can fasten the grub screw in that position, and also on the other side. Right, so I managed to get the 16mm MDF Wasteboard in. However, it was a little bit of a tight squeeze. So What I'm going to suggest to you guys is that the aluminum extrusions that in the previous step that we have, the ones on this side here, on the previous step that we have set in by about 20 millimeters, I would suggest maybe push that up to about 30 millimeters, 25 or 30 millimeters, and then cut your wasteboard in width to just under 950 millimeters. That way the wasteboard will be able to fit in within the distance between these two aluminium extrusions, and then you won't have a problem to fit that in. Yeah, so when you move this gantry across to as far as it can go, you're never going to be able to cut this far anyway, so you don't have to worry about losing cutting area. That won't happen. So we also have a number of bolts and T-nuts. These are, I think they're M5. And T-nuts that we are going to use to secure the wasteboard to the aluminium frame. So what I've done is I've just pre-marked where I'm going to be drilling these holes. So I'm just centering these holes over the channel in the aluminium extruder that runs underneath the wasteboard. And I'm just putting them as far as possible into the corner that I can. I'm just going to drill all the way through, just making sure that I don't touch the extrusion. There we go. And then we can pop the T-nut in from the other side. And then we can secure the wasteboard. And I'm going to do this in each of the 4 corners of the wasteboard.